Remember the first lecture of this section? We gave an example about 6 countries: USA, Canada, France, UK, Germany, and Australia. Well, guess what? This was not just for illustrative purposes. In fact, we are going to cluster these countries using k-means in Python. Plus, we'll learn a couple of nice tricks along the way. Cool. Let's import the relevant libraries. They are pandas, numpy, matplotlib, pyplot, and seaborn. As usual, I will set the style of all graphs to the seaborn one. In this course, we will rely on scikit-learn for the actual clustering. Let's import k-means from sklearn.cluster. Note that both the k and the m in k-means are capital. Next, we will create a variable called data, where we will load the CSV file 3.01 country clusters. Let's see what's inside. We've got country, latitude, longitude, and language. Let's see how we gathered that data. Country and language are clear. What about the latitude and longitude values? These entries correspond to the geographic centers of the countries in our dataset. That is one way to represent location. I'll quickly give an example. If you Google geographic center of US, you'll get a Wikipedia article indicating it to be some point in South Dakota with a latitude of 44 degrees and 58 minutes north and a longitude of 103 degrees and 46 minutes west. Then we can convert them to decimal degrees using some online converter like the one provided by latlong.net. It's important to know that the convention is such that north and east are positive, while west and south are negative. Okay, so that's what we did. We got the decimal degrees of the geographic centers of the countries in the sample. That's not optimal, as the choice of South Dakota was biased by Alaska and Hawaii, but you'll see that that won't matter too much for the clustering. Right, let's quickly plot the data. If we want our data to resemble a map, we must set the axes to reflect the natural domain of latitude and longitude. Done! If I put the actual map next to this one, you will quickly notice that this methodology, while simple, is not bad at all. All right, let's do some clustering. As we did earlier, our inputs will be contained in a variable called x. We will start by clustering based on location. So, we want x to contain the latitude and the longitude. I'll use the pandas method, iloc. We haven't mentioned it before, and you probably don't know that, but iloc is a method which slices a data frame. The first argument indicates the row indices we want to keep, while the second, the column indices. I want to keep all rows, so I'll put colons as the first argument. Okay. Remember that pandas indices start from 0. From the columns, I need latitude and longitude, or columns 1 and 2. So, the appropriate argument is 1:3. This will slice the first and the second columns out of the data frame. Let's print x to see the result. Exactly as we wanted it. Next, I'll declare a variable called k-means. K-means is equal to capital K, capital M, and lowercase eans, brackets, 2. The right side is actually the k-means method that we imported from sklearn. The value in brackets is the number of clusters we want to produce. So, our variable k-means is now an object which we will use for the clustering itself. Similar to what we've seen with regressions, the clustering itself happens using the fit method. K-means dot fit of x. That's all we need to write. This line of code will apply k-means clustering with 2 clusters to the input data from x. The output indicates that the clustering has been completed with the following parameters. Usually, though, we don't need to just perform the clustering, but are interested in the clusters themselves. We can obtain the predicted clusters for each observation using the fitPredict method. Let's declare a new variable called identified clusters equal to k-means dot fitPredict with input x. I'll also print this variable. The result is an array containing the predicted clusters. There are 2 clusters indicated by 0 and 1. You can clearly see that the first 5 observations are in the same cluster, 0, while the last one is in cluster 1. Okay. Let's create a data frame so we can see things more clearly. I'll call this data frame Data with Clusters, and it will be equal to Data. Then I'll add an additional column to it called Cluster, equal to Identified Clusters. As you can see, we have our table with the countries, latitude, longitude, language, but also cluster. It seems that the USA, Canada, France, UK, and Germany are in cluster 0, while Australia is alone in cluster 1. Cool! Finally, let's plot all this on a scatter plot. In order to resemble the map of the world, the y-axis will be the longitude, while the x-axis, latitude. But that's the same graph as before, isn't it? Let's use the first trick. In matplotlib, we can set the color to be determined by a variable. In our case, that will be cluster. Let's write C equals data with clusters of cluster. We have just indicated that we want to have as many colors for the points as there are clusters. The default color map is not so pretty, so I'll set the color map to rainbow. CMap equals rainbow. Okay. We can see the 2 clusters. One is purple and the other is red. And that's how we perform k-means clustering. What if we wanted to have 3 clusters? Well, we can go back to the line where we specified the desired number of clusters and change that to 3. Let's run all cells. There are 3 clusters as wanted, 0, 1, and 2. From the data frame, we can see that USA and Canada are in the same cluster, France, UK, and Germany in another, and Australia is alone once again. What about the visualization? There are 3 colors representing the 3 different clusters. Great work! It seems that clustering is not that hard after all. In the next lesson, we will cluster the observations based on a categorical feature. Thanks for watching.